Hello, my name is Adit Mishra, and I have did MSc in physics, and after that I did B.Ed, and now I am pursuing M.Tech in material science engineering from IIT. But today I am discussing topic electrostatics, and subtopic is basically Coulomb's law, and under which I am discussing what is charge and method of charging and conservation of charge and what is force, and after that we will explain the what is Coulomb's law and its application, and after that we will discuss superposition principle, and after that we will discuss some numericals. Okay. So charge is the form of outermost electron of a material or matter. So when we rubbing two bodies by creating some kinetic energy on the matter, the electron move out from one body to another body. So one body, one matter which lose the electron, that becomes positively charged, and secondary body which accept the electron, that become negatively charged. Okay. So charges are three types basically. Positively charged body and negatively charged body and neutral body. Okay. Now after discussing the what is charge and how we can create the charge, and now we are discussing the Coulomb's law. The statement of this law is that if two stationary point charges having some distance between them, then they create force on each other. If the nature of the charge are similar, then they repel each other, and if the nature of the charge is opposite, then they attract to each other. This is basically a fundamental statement of this Coulomb's law. Now coming to the how can we see that these are two charges Q1 and Q2 which are kept some distance, let's suppose R. If the charge are in the same nature, let's suppose both are positive, then they repel to each other. This is basically a line of force between them, and they will repel to each other. Let's suppose this is a force 1 2 and this is force 2 1. So the force 1 2 is force on charge Q1 due to charge Q2, and this is force 2 1 which is basically force on charge Q2 due to charge Q1. If let's suppose charge are in opposite nature, like one is positive and second is negative, then they attract each other like that. This is force 2 1 and this is force 1 2. This force 1 2 explain that the force on charge Q1 due to charge Q2, and F2 is again the charge on force on charge Q2 due to charge Q1. Here they are attracted to each other because of they are in opposite in nature, and here they are both are positive charge, so they are repelling each other. Okay. So according to the statement, if two charges are having some distance r, then the force can be proportional to the multiple of magnitude of charges and anti-proportional to the square of distance between two charges. As we know, the unit of this force is Newton. In MKS system, and if we remove proportionality sign by equality sign, then there is some constant called we can say the Coulomb's constant, and Newton. The unit is Newton. So this is a mathematical form of Coulomb's law, by which we can explain the force on 2-point charges. And here value, this is K is proportionality constant, basically Coulomb's constant. For different medium, the value of K can be varies. So for air, value of K equal to K is 1 upon 4 pi epsilon. The epsilon is permittivity of air. So the total value of K is 9 into 10 to power 9 Newton meter square per Coulomb square. So coming on the principle of superposition. So if we have a system with different point charges, so how can we calculate the charge on a 1-point charge due to another different point charges? So let's suppose we have a system of different point charge. If we have to calculate the force on this point charge due to another point charges, how can we calculate this the force on this charge? Let's suppose this is Q and these are Q1, Q2, Q3 and Q4. So principle of superposition. Let's suppose a total force on this charge is F. So total force on the charge Q is a vector sum of forces due to other charges. So let's suppose force due to charge Q1 is F1, and due to charge Q2 is F2, and due to charge Q3 is F3, and due to charge Q4 is F4. So this is basically a vector sum of these all forces. So F1, F2 plus F3 plus F4 and so on. This is called a principle of position of superposition. The sum of addition of all these vector sum of all these forces is total sum of the force on this charge Q. So the force can be effect with the medium. If we have two charge in air like Q1 and Q2, having distance between them is R. If they are kept in air medium, in air, then force is like 1 upon 4 pi epsilon Q1 Q2 upon R square. If they are putting in some dielectric medium having dielectric constant K, then the force will be like, the second is Q1 medium is air, and here in some dielectric medium having dielectric constant is K. So the force is given by formula K Q1 Q2 upon r square. And if we impose here some constant k, for k is 1 for the air, and here value of k will be greater than 1 for some dielectric medium, greater than 1 for dielectric medium. So from comparison of these two forces, if value of k is greater than 1, then the force between two charges in dielectric medium is less than the force between two charges in air medium. So here we can see F1 is greater than F2. So in final conclusion of this law, we can say how two charges attract or repel to each other, and how the medium affect the nature of forces or magnitude of the forces. This is basically fundamentals of Coulomb's law. So now coming on the application and numerical part. So application of this Coulomb's law, how we can find with the help of Coulomb's law the force between in chemical bonding, and in capacitor the force between two plates, like that we can find the force. So now we are solving one numerical here. The numerical is the two equal charges of each of 3 microcoulomb are separated by certain distance in meters. If they are located at distance I plus j plus k, and another is 2i plus 2j plus 2k, then the electrostatic force is what? So let's suppose there are one charge is here 3 microcoulomb I plus j plus k in a space in somewhere, I plus j plus k, and another is also 3 microcoulomb charge, point charge, which is at position 2i plus 2j plus 2k. So you can find the distance between two charges by the formula r equal to x1 minus x2 का whole square plus y1 minus y2 का whole square plus z1 minus z2 का whole square. So by putting let's suppose this is x1 y1 z1, and this is x2 y2 z2. So putting these value, we can get 1 square plus 1 square plus 1 square. So the r is under root 3 meter, because they also given the distance in meters. Okay, so now coming to the formula from Coulomb's law, and here they are not mentioning the medium, so we are considering the medium is air. So formula is 1 by 4 pi epsilon q1 q2 upon r square. So value of this is 9 to 10 to the power 9, and q1 and q2 is given 3 microcoulomb. So in micro we are putting 10 to the power minus 6, and again second charge is also 3 microcoulomb, so 3 into 10 to the power minus 6 coulomb. And now r, we calculate the value of r is under root 3, so putting r square is directly 3. So 3 is now cancel. So 9 3 are 27 into 10 to the power 9, and 10 to the power minus 6 is now total is 10 to the power 3, and now here 10 to the power plus 3 and 10 to the power minus 6. So now value is coming out 10 to the power minus 3. Okay, so force is 10 to the power minus 3 Newton. This is final value you can get from this formula. And here charge is positive, so as in the question they are mentioning the charge is positive, so we are getting the value of force is positive. So the nature of force is they are repelling, the charge particle is repelling to each other. That's it. Thank you.